Okay, moving on to the most popular question from all of you is about the ice diagram. So the first question is that whether ice diagram can only be used for weak acid or not. So actually the ice diagram can be used for both weak acid and strong acid. So the only difference is that in the change for the strong acid, because it dissociates completely, means that it will dissociate completely. So it won't have the negative value of X. We will have a very specific value for X. So I'm going to explain more about this in the following video. For the ice diagram, you will have two different types of ice diagram. One is for the strong acid and the other one is for weak acid. So the pattern is the same. So assume that the initial concentration for the acid for both strong and weak acid is 2. So initially the concentration is 2. So for a strong acid, initially there will be no dissociation. So you have 0 and 0. So same like the weak acid, there's no dissociation. Initially there's no dissociation. You only have that particular acid. Alright, in strong acid, because it dissociates completely, that is why in change you will have -2. You will not use the X, and because you will form the dissociated things or the product, so the product should be equivalent to whatever it have been dissociated out. So this one will be +2, +2. But on the other hand, for weak acid, it doesn't dissociate completely, so we are going to assume how much dissociation is going to occur. So since the reactant will decrease, so we put -X, always -X at the reactant. Okay, so here, because of the formation of things, so we will have +X and this one will be +X. So at equilibrium, definitely for strong acid there will be no more and it became like 2 and 2. But for weak acid you will have 2 minus X, X and X. So this is the difference between the ice diagram of strong acid and weak acid. So for strong acid, definitely you cannot calculate the Ka. If you want to calculate the Ka, it's like 2 times 2 divided by 0. So there's no point of doing that, because usually in the strong acid, what you want to know is from the ice diagram, the most important part is you look at the H+. So from here, if it's 2, so you can directly calculate the pH is equivalent to -log your H+. So you already know the value of your H+ is equivalent to 2, so the pH is -log 2. So we get around -0.1 something. -0.3011. So this is the pH value for the strong acid itself. But for the weak acid, you seriously need to calculate what is the value of X, and you move on from there, because you need to check whether the value of X is valid, because we are going to use the approximation method. So yeah, we are going to continue on in calculating the value of X. Alright, one of you did ask if you have this kind of question in the question given to you. So how are you going to predict what is the product? So in the question, usually in acid and base, usually what I will ask is about the neutralization. So if you want to neutralize these things, means that one of the products shall be water. So you need to add water to your product, H2O. So another product that will be formed is the thing that you need to learn how to find what is the other thing that you are going to produce. So I'm going to go through this. So H2SO4, so definitely you need to cut it into 2, right? So H should be H+, and SO4. if you can't remember SO4 is 2 minus, you just need to look at your H. So H is H plus, right? Definitely you will remember that. But since you need 2 here, so it means that there must be something with the SO4. So you need 2H, means that you need to have 2 minus around here. So to balance this up, just 1 positive, 1 plus. So in order to balance out with 2 minus, you need to have 2 molecular of H. So you have 2H around here. So for sodium hydroxide, so you will have the OH and sodium. If you don't know the charge for sodium, because you only have OH minus, so sodium must be plus, right? Okay, because this is an ionic bonding, so you just need to swap. See, for example here, you will have H plus and also the SO4 2 minus, right? So at first, H and SO4 is linked together, and Na and OH minus is linked together. Since you are going to form water, H2O, so this one will be attracted to this one. So this one will merge together, right? So H2O, so you will have H2O. But now, how many H do you have? 1, 2, 3. You have 3 H and 1 O, right? So now you are, when you create H2O, means that you are having 1 extra hydrogen from this actual equation. So just bear that in mind first. And then for sodium, sodium is Na, right? So in order for the Na to balance out with the SO4 2 minus, you need to have 2 sodium around here. So you will have Na2SO4. Okay, so since that you have Na2, here at the moment you only have 1 Na. So around here you need to put 2 so that you will have 2 Na. Okay, so now we need to count again. So oxygen, here you will have 2 oxygen. So 2 times 1, so it means that you have hydrogen, 2 hydrogen, and around here you already have another 2 hydrogen. So total of hydrogen you should have 4 hydrogen around here. Okay, so if you look here, SO4 you already have 4 O's around here, so that's fine for this one. But for this one you only have 1 O, but you actually need 2 O's. So you need 2 times 2 here. So 2 times 2 equivalent to 4. So here you do need 4 hydrogen. So 4, and you do have 2 oxygen here. So this is your balance equation. Alright you guys, I think that's about it. I have already covered all the questions that you have asked. So once again, thank you very much for all the questions being asked to me. So if you have more questions, you may ask in the comment section in this YouTube channel, or you may ask personally during our lecture. So thank you very much once again. Goodbye.